Here we are in the week of November 10th, and I want to show you a few ways to calculate statistics that'll help us in our data analysis next semester. You might want to view this video to help you through some homework assignments or to help you through some lab reports next semester. So here we have a couple of data columns where students have measured the masses of 10-gram masses repeatedly, and then they repeatedly massed a 200-gram mass. And they did this, what is that, about maybe 35 times or so. And we're going to crunch some statistics on these measurements. So first, we need to identify if there's any data, any of these measurements that we don't trust. In other words, they are outliers. Just by surely being too far from the main data sets, we don't trust them. So you might recall that the way we identify outliers is we must find the first and third quartiles, and then the corresponding interquartile range, and that'll give us the lowest valid potential measurement and the highest valid potential measurement. After we've weeded out our outliers, we will find the average value of each column. We'll quantify the precision of the data by finding the average absolute deviation. And finally, we'll assess the data accuracy by finding the percent error. First, finding the first quartile. What we want to do is we will type equals, which again prompts the computer so that the computer knows the calculation is being requested. So we type equal sign. We are interested in finding the quartile, and we need to highlight the data we want the computer to look at. And then we need to type comma 1 because we're interested in the first quartile. So the 1 represents the first quartile. To find the third quartile, it's the same thing. Equals quartile. Highlight the data. But rather than a 1 this time, we want to type a 3 for the third quartile. The interquartile range is the difference between the third quartile and the first quartile. In other words, it's the middle 50% of the data. So that's equal to the third quartile minus the first quartile. The lowest potentially valid measurement would be, as you might recall from class, equal to the first quartile minus 3 times the interquartile range. And the highest would be equal to the third quartile plus 3 times the interquartile range. So the way we interpret these numbers is any number less than 9.87 or greater than 10.15 in the data set is considered an outlier and therefore is not used in any subsequent calculations. So if we look at this data, this column of data, we do not find any number less than 9.87 or greater than 10.15. Okay? So there is no outlier in the column A. Therefore, we can simply calculate the average measurement by highlighting all of that column A data. We can find the average absolute deviation by simply typing equals avdev, which is the shortcut command for absolute average deviation, and highlight the data. And percent error, unfortunately there's no shortcut command for that, so we need to do it the long way. So there we would want the absolute value of the difference between the average and the known value. In this case is 10 gram mass. And parenthesis placement is very important. You can look up here in your formula bar. And we want to divide by the true value, which would be the 10 gram mass. And it's expressed as a percentage, so we need to multiply it by 100. The corresponding calculations will be the same for column B if there are no outliers. But first we need to determine whether there are outliers. So we can just click the bottom right corner of the highlighted box and to click and drag to copy the formula. So the first quartile for the second column data is 199.94. The third quartile is 200.01. The lowest value, the lowest potentially valid measurement would have a value of 199.74. Question is there any data less than 199.74? And yes, there are 3 of them. 199.01, 199.08. I'm highlighting them red as measurements that we do not trust because they are outliers. And then 190.05 is considered an outlier. For the uppermost valid measurement would be 200.21. Is there a measurement in this column greater than that value, 200.21? The answer is no. There's no measurement that exceeds 200.21. So we found 3 outliers on the low end. So now when we calculate the average, we don't want to find the average of all the data. We need to find the average of only the data we trust, so the non-outliers. So we can click and drag, but then we need to skip over the outliers. The way to do that is to hold the control key down and hold the control key down. You got to keep the control key down. And then same thing for calculating AAD. We need to do the avdev, highlight the data, hold the control key down to skip the outliers. And there's the absolute average deviation, and then percent error would be found the same way as the previous column, with the exception that the true value is no longer 10 grams. As you might recall, students measured a 200 gram mass for column B measurements. So the true value is 200 grams. And it's considered infinite decimal places for these purposes because the manufacturer stated that the masses have a mass of 200 grams, so 200.000 grams for our purposes. So it's a 0% error, which is pretty darn good. Let's just confirm that. So it's taking cell B46, which is the average, minus the 200, so it's a difference of 0.01, divided by 200. Rounds to 0. So that all works. I hope you found this helpful. If so, we can do more of this in the future. Good luck.